Hello class, good day. Welcome to our lecture 5 for our subject Statics of Rigid Bodies. Today we will talk about equivalent systems of forces. Okay, let's proceed. Essentially, the treatment of a body as a single particle is not always possible. We have talked about this on our introduction part or in our first lectures that we will deal with bodies that sometimes that can be considered as single particle. So for example, trucks, cars. Um, from the visual representation of cars, you already have four wheels. So for each wheel, you already have four normal forces and weight, right? So it is not always possible to treat those forces as one. In general, the size of the body, the specific points of application of the forces must be always considered. Thus, we will now introduce the concept of the line of action. Most bodies in elementary mechanics are assumed to be rigid, meaning fixed. Deformations are small and negligible. But take note, class, that deformations and deflections will be considered on the next on the next subject on statics, which basically on mechanics of materials and theory of structures. So get ready for that. So again, a recall for our definition of rigid body: a body which does not deform under the action of forces. So a body is in finite size in which deformation is neglected or very, very small. Okay, next. External and internal forces. The action of other bodies on the rigid body under consideration. The external forces either cause a body to move or a body to stop. The internal forces are the bodies within the body, are the forces within the body which will be discussed in your stresses, okay, in your mechanics and in your mechanics of materials. Now let's talk about the principle of transmissibility or equivalent forces. Now we need to understand here, class, that the principle of transmissibility just basically states that if I move the force, as long as this force is equivalent to that force, as long as it acts on the same line of action, it will just be the same. Okay? So for this example, maybe the force F is pushing the box, right? Is pushing the box. But in this case, the force F is pulling the box. So that states that the force here is a push force, but in this case, a pull force, but it is equal because on the same line of action. So Tagalog, tinutulak ko dito, pero dito hinahatak ko. But equivalent lang yung force na ginagamit ko with a magnitude of F and on the same line of action. That is the principle of transmissibility. Okay, now let's just recall on the vector product of two vectors. Basically, it's just the cross product. Okay, the cross product. So in this case, we were using the right hand rule, wherein in this case, the vector p multiplied by vector q with an identified angle of inclination of theta is simply pq sine theta. Okay, the magnitude of v. So in this case, this is taking note the class that this is a three-dimensional. So P cross Q will give you a rising force or a product vector upward. Okay? So from the right hand rule. Okay, so this is your right hand rule, right? Okay, so the force vector points upward. Okay? The magnitude of vector V is the product of the magnitude of PQ and the sine of the angle theta. So as I said earlier, the magnitude of V is PQ sine of the included angle theta. Okay? So very basic. Just follow the instruction. Okay? So close your hand. So point your four fingers to the direction of P and then twist it up to the angle Q or the direction of Q. And where your thumb points, it will be the direction of your vector product. In this case, vector V. Okay, so in this case, the thumb will then indicate the direction of vector v. So some other characteristics that we need to identify. PQ sine theta multiplied by the vector product. So we have already introduced the vector product or the unit vector, sorry, on the last lecture. Okay, so the magnitude multiplied by the unit vector is just simply the vector itself. Okay, the magnitude of the vector v, which is PQ sine theta multiplied by its unit vector, is the whole vector v. Okay, so some properties that you need to remember that when you deal with vector product, because this is very important for you to analyze or to understand. The vector product is not commutative, okay, but can be used like this. And associative with respect to scalar multiplication. Take note, scalar, scalar quantity yung k. So, hindi siya vector. Okay, so let's say k is a constant. So, pwede siya. It can be done. Associative. Distributive with respect to vector addition. So, possible also for vector addition. Okay. Next, the cross product in terms of components. So, in this case, we are now dealing with the force or the unit vectors I, j, and k. So, simply, I, j, or I cross j is simply k hat. So, in order for you to memorize this, there is actually an what do you call this? A schematic. This is your diagram. So, I cross I is 0. J cross I is k. K cross I is j. J hat. Okay. So, I can explain this visually on our live explanation or in our before your quizzes in order for you to understand properly because it's hard to demonstrate in this case. So, we're using this circle, okay? So, I cross j is k hat. K cross I is j hat, okay? J cross k is I hat, okay? There's one. So, how about I cross k? So, that will be negative j. So, that will be it. So, if it's counterclockwise, it will be all positive. If clockwise, it will be all be negative. So, take note of that. And if it's all k cross k, if it's the same, the vector product is the zero vector. Okay? The zero vector is 0 I hat plus 0 k hat plus 0 j hat. Okay? The j hat class is also just a representation of the term hat. Okay? That is a representation of the arrow up on the top. So, this is our visualized hat. Parang sombrero, the cap of the letter. So, if you can read this, I hat cross k hat is equal to negative j hat. Okay? So, some other visualization in order for you to remember the cross product of two vectors P and Q expressed in terms of their component is simply the following. So, actually, class, this is just your Kramer's rule, your determinants, okay? So, the result can be compactly written as the determinant as the following. So, I hope you remember your linear algebra. You can easily solve this product. Okay? Let's look on this example. The cross product of U cross V of the vectors U, negative 2i hat plus j hat, and V, 3i hat minus 4k hat. So, U cross V is simply the following. You can easily write in this term, negative 210 because 0k hat and 304, negative 4 for the V vector. So, crossing multiplied, I cross I multiplied by 1 times negative 4 will be negative 4i hat. And where did 8 come from? So, in this case, negative 2 multiplied by negative 4. That will be positive 8, right? Why negative 8 here? Because of the I cross K. So, I cross K here is I cross K, that will be negative J hat. So, getting the negative 1 will give you negative 8. And finally, for your K hat, 1 multiplied by negative 4, J times K is positive. Sorry about that. So, that will be Where is the k? That will be j multiplied by k. This one. Ah, j multiplied by cross k. J cross I is negative k. So that will be negative 3. 1 times 3 times j times negative cross I is negative k. So that will be negative 1 multiplied by 3. Negative 3k. Okay? Now, actually, the application of that or the cross product is simply in this part, okay? The moment of a force about a line or the moment of a force about a point. Okay, class. First, let's define a moment. The moment is the ability of a force to make a body rotate. Okay, take note of that. The moment of a force is the measure of tendency of a force F to make the rigid body rotate about a fixed axis perpendicular to the plane of the force F. So in this case, F is perpendicular to the plane, okay, to the plane. So with the moment arm, with the moment arm R, you call the moment arm R, in this case position of vector F, from point A, from O to A, okay? So that will be, the moment is simply out to the page. So in this case, the moment is simply R cross F, which will give you a vector. Okay, so that means that the moment is a vector. Okay, now we are introducing now a new, what do you call this? A new concept. So that's why you need to understand this properly. And the magnitude of M is simply RF sine theta, where theta is the angle of inclusion of R and F. Okay? Excuse me. Busog. Where D represents the perpendicular distance from O to the line of action of F. Okay? In this case, the two forces F and F prime are equivalent if and only if they are equal, have the same magnitude and same direction, and have equal moments about a given point O. The Varignon's theorem essentially states that the moment about a given point O, actually we will be discussing this when we talk about the centroid, okay? But for this case, it's simply the summary of all forces. And the summary of the moment arm, you can easily distribute it in this case. Okay? The Varignon's theorem makes it possible to replace the determination of the moment of a force F by the moments of two or more components forces of F. So in this case, if you have so many forces, first I can simply get the resultant, okay, from our lectures 3 and 4, right? We can easily get this and then get the moment arm and cross product, and you will get the moment. Okay? So the rectangular components of the moment of a force. The moment of F about O is simply the following. R cross F is simply like this one. So you can easily again use the Kramer's rule or the determinant matrix in order for you to solve. Okay? So some more illustration. Let's look on this example. The line of action of the 90 Newton force passes through points B and C. What is the moment of force about point A? So what is the rotating force about point A? Where in this case, this is your point A, okay? So nawalan lang ng letter. There's missing letter A. Let's write the letter A there. Letter A here. Ah, there it is. I was blindsided. Okay. So the what you call this? The components or the coordinates of A is 506 and the coordinates of B 411, 0. So from this case, you can simply get the moment arm using the distance formula. Okay, we can get the distance vector. That will be 4 minus 5, 11 minus 0, and 0 minus 6. Okay, and then, now, to evaluate the cross product, we need components of F first. How do we identify the components of F first? So this will be the point C to point B. Let's get first the unit vector, okay? The unit vector. So that will be 7 minus 0, or 0 minus 4, 7 minus 11, and 7 minus 0. Okay? Divided by the total, what? The total resulting magnitude, okay, of the length using the Pythagorean theorem. So that will be this one, okay? And multiplying it to the total magnitude, okay? So that will be 4 square, what do you call this? The difference, -4, -4, +7. So 49 plus 36. Ano ba? 49 plus 32. That will be 81, right? Okay, so the unit, the vector of this one is 0 minus 4. That will be -4, okay? 7 minus 11, that will be -4 also. And then finally, 7 minus 0, that will be +7. Now, if I get the Pythagorean theorem, getting the hypotenuse of this one, the magnitude of this is square root of 4, -4, that will be 16, plus square root of 4, that will be 16 also. And the square of 7, that will be 49. So, square root of this, 32 plus 49, that will be 81. Square root of 81, that will be 9. That's why this is 9, okay? So, this is your unit vector, so for each component. And multiplying it to the magnitude of the total force, which is 90, in this case, 90 newtons. So, will give you this force, okay? Next, we are to get the vector, the moment arm of R. So again, just minus the coordinates, and then what is the purpose of this one? In order for you to get the moment. Okay, so this is very straightforward. The moment arm cross the force. So using Kramer's rule, this is very straightforward. I cross I, this one, and then this one. Okay. Minus the following upward, minus this, minus this, minus this. All downward are positive, all upward are negative. Okay? So that will be it. The moment at A is simply a vector. You can easily rewrite this as like this. 530, 310, 480, and then close bracket. So that will be it for a moment. If you have any questions, class, or clarification, comment down in this video. Message me now my Facebook or email me. Thank you all and God bless you all.